Yeah, thanks everyone for joining this webinar. Today's session, we will be talking about build, train, and deploy your ML application on Amazon SageMaker. My name is Praveen Jayakumar. I'm a solutions architect with AWS, and I'm joined by Puneeth Kadamba, who is an engineering manager with redBus, who will talk about how they are solving some interesting ML problem using SageMaker. So before we get into SageMaker, let's talk about the AI/ML stack, the Amazon AI/ML stack, which has three layers in it. The first layer is application services layer. In this layer, what we do is that we give you APIs for you to work on image, language, and chatbot. For example, we have this recognition, which is an API provided for you to work on images and videos, and you have transcribe, translate, poly, comprehend. These are some of the API services to do translation, convert text to speech, speech to text. So those kind of services are provided as an API. Right. So that's the first layer, the application services layer. And the third layer, which we have, is a framework and interfaces layer. In this layer, what we do is that we support all popular frameworks, the ML and deep learning frameworks, right from TensorFlow to Apache MXNet to Caffe2. And we also support different interfaces like Keras and Gluon. Right. So typically, if you see in this layer where we have, you need deep understanding of the machine learning frameworks and deep learning frameworks. And if somebody is very comfortable in that, they will be working at this third layer. So the first layer is for developers who just want to call an API and get things done. That's the first layer for them. And the third layer is for someone who has very good understanding of deep learning frameworks and they want to go work on it. The third layer is they would be working on it. But for people who's like wanted to start on AI/ML as a developer, let's say I'm a Java or a Python developer who wanted to start on AI/ML, that is where we have this platform services layer. We call this as a democratizing AI, where we wanted to take the AI/ML to every developer who knows a language like a Java or Python they wanted to start working on. So that's where this platform services layer comes into picture, and that's where Amazon SageMaker fits in. Right. In this layer, we do have another services called DeepLens, where it's a device where you could take the model which you have built and you want to do some kind of a testing, then you could do it using DeepLens. But in this session, we will be talking about Amazon SageMaker and how it helps you to build a machine learning problem, basically, right, to solve a machine learning problem. So let's talk about a typical machine learning process. Like with any problem, you start with the business problem you want to solve, and then frame it into a machine learning problem, like what you want to do, what is the output you require. So that's the machine learning problem you kind of convert that into. And then what we do is that you go collect the data. Let's say if you are trying to solve a credit card fraud problem in a transaction, then you need to have a previous data of what all the credit card transaction that has happened and which is a fraud, which is not a fraud, right? So that kind of a data you need. Let's say if you're trying to solve a problem, trying to find from an image whether a particular a person has a skin cancer or not, you need to have different images of the skin cancer, whether that particular image is a cancer or not. You need to have that kind of a data. So the first thing you do is that go collect the data. So once you have the data, you might want to integrate the data with other things, because sometimes a particular problem might have a dependency on certain external factors. So you want to identify those external factors, and that's where you do this data integration. And then you do a data preparation and cleaning. In fact, if you talk to most of the data scientists, they would say that they spend most of the time, more than 50% of the time in this process, where they have to make sure that the data they're feeding in is without bias, and it's cleaned as well, right? Because a lot of time you get a lot of noises in the data, so you have to clean the data, where you spend a lot of time. And then once you have prepared the data, then you want to visualize the data and see how the data looks like, and you want to do some amount of analysis before you proceed further. And then the next step in this process is what we call it as feature engineering, which is extremely important. Let's take an example to talk about what is a feature engineering. Let's say in my database, I have multiple columns. So one of the columns is door number, then another column is street name, and then another column is a zip code, right? So let's say if the street name is 7, I mean, I might have a data like a 7 as my but the 7 as my door number, and you might have a data 7 as your door number, right? As that column alone really doesn't make any sense, or it doesn't give much information for us, right? But when you combine this data, when you combine your door number, street name, and zip code, then it makes a lot of meaning to it, right? So you could analyze, you could do a lot of analysis based on that, right? So this concept of combining the data or breaking the data into multiple pieces is called feature engineering, and it's very important aspect in the machine learning world, right? So let's assume that you have done your feature engineering, and then you need to select your algorithm for the same set of problems. There could be multiple algorithms which you can use. So you select the algorithm, pass the training data, and then what you do is that you create a model out of it, right? So once you have the model, you want to evaluate the model. There are different based on the algorithm, there are different ways you could evaluate the model, whether it's working for your data or not. And then you finally go and see if the business goal is met. If it is not, then you go back and add your data. Probably you might want there are a lot of data missing, so you might want to go add few more data, or you want to feature engineering, right? Again, I talked about feature engineering, which is a very important aspect. So you might want to kind of combine or add few more columns for the data to make sense. So that you go back and start doing it. Let's assume that if the business goals are met, then you need to deploy the model for somebody to consume, other applications to consume as an API. And then you again start monitoring and debug. And if there are any errors, or you want to retrain the model, this cycle keeps going. So this is a typical machine learning process which happens in any machine learning problem you want to solve. So let's break this into two things. So the first part is the data part. In this part, really, SageMaker by itself doesn't really help you, but there are various services from AWS which can help you in this data part. We have our S3, which is our object storage, Glue, which can do your ETL process, completely serverless ETL process. Athena, EMR is our managed Hadoop services. So all these services together help you in collecting and cleaning the data. These services can help you over there. In the second part of the problem, where you wanted to do visualization, lot of people currently use frameworks like Matplotlib or NumPy is one of the popular things that is used. Then you select your algorithm. If it's an ML algorithm, probably you might be using a Spark ML or scikit-learn. Or if you're doing any deep learning framework, then you might be using MXNet, TensorFlow, or some of the other interfaces like Gluon and Keras. And for this evaluation of the model based on the algorithm or based on the problems you're trying, if it's a classification problem, then probably you might be using FN score, which is a popular way of evaluating. Or if it's a regression, you might be using RMSE. So one of the methods you would be using while doing the second part of the process, right? And this is the place where SageMaker can help you. So SageMaker provides you a notebook environment, completely configured Jupyter notebook environment. Jupyter is a popular notebook framework which a lot of people in the machine learning world uses. So we provide you that environment. We help you in setting up and managing the training cluster. Training is a very important aspect in machine learning, because you might want to do your training. Let's say if the data size is huge, you might want to distribute it and train your algorithms. So setup and managing the training cluster is important. And then one of the important aspect is that so you identified an algorithm, and then you want to scale it, distribute it, and run the training, because you don't want to run it in one machine, because then you might end up doing the training for 2 days or 3 days. You want to distribute it across 10 or 20 machines or 100 machines and have the ability to run the training. That is one of the key concepts which SageMaker could help you over there. And then once you run the training, you got the model, you want to store the model in a secure manner and deploy it and you want to deploy it, right? So that's again SageMaker could help you over there. So this is the training, and once you till the model creation part of it, right? So once you have the model, you want to have the ability to deploy the model and scale the model as well. Let's say if your model is successful, a lot of your people in your company wants to use that model. So what SageMaker can do you is that the SageMaker can deploy the model for you and give an API, right? So that API endpoint can be used by your multiple developers or other applications can start using it. We help you in do auto scaling. As and when the load increases on this API, we can auto scale by itself, and the load goes down, we can come back to the minimum size. We help you in tracking the version of the model, and we also help you in doing a A/B testing, right? So you could decide this particular model, I want to send 75% of the traffic, and the new model I created, I wanted to send 25% of the traffic, and see how the results are, how people react to it, and then probably make that model as my main model where I can route all my 100% of the traffic. So this is the place again where SageMaker can help you. So as I said, there are four different places where SageMaker can help you. The first, it has a notebook services, Jupyter notebook. So when you start at SageMaker, we give you a completely built-in Jupyter notebook, and that's workspace readily available for you, that you could start using right away. You could start with a small machine, or you could also create this notebook in a GPU powered machine. So if there are some customers of us who wanted to try out some algorithms within the Jupyter notebook itself. So for them, they might need a powerful machine more than the CPU. So we give you a GPU version of it as well. You could select it which type of machine where you want to run your notebook interface. And the second thing is, as I said, we give you SageMaker algorithms, and these algorithms are written grounds up, right? So what do we mean by that is that we have taken some of the most popular algorithm people use in the ML world. We have written it grounds up, we have written it from the grounds up. So, and one of the things while doing we have done it is that we made sure that most of these algorithms can be distributed and run in parallel, right? So instead of the ability to run it in one single machine, we could distribute it, run it parallel across multiple different machines. So that's the capability which we brought in. Currently, we support 14 different algorithms. I'll talk about what are the algorithms in the future slide, but we support 14 different types of algorithms at this point of time. And but there is a very good chance that apart from this algorithms, you might want to write your own algorithm, or you might want to bring an algorithm which you have written it elsewhere. That is also possible. We'll talk about it in the next slide on this. And the third benefit or third feature which SageMaker gives you is the training service. So we call it as one-click training, where you could say that, hey, this is my algorithm, this is where I have my data, go run it in create 10 different instance, distribute it and run it, right? So you just give us this one-click API call, and then what we do is that we take your algorithm, we take the data, distribute it across, run it, and give you back the model, right? So that's the one-click training service that is available. In the same way, we also support the deployment process. Once the model is ready, you want to deploy it, you just say that, hey, this is where my model is, go deploy it in what type of machine and how many instances you want to deploy. Go deploy it in 5 different instances. We deploy it across 5 different instances, put a load balancer on top of it, and give you one API where your customers or your developers can go start accessing those models. They can start doing the inference on the model, right? And one critical aspect of this is that you don't need to use all these four features of SageMaker together. SageMaker is modular. If you want to use only the training, you could just do the training, create a model out of it, take the model, and you could deploy it by your own ways. If you might want to deploy it in your own data center, your own environment, you could still go ahead and do it, right? Same way, if you want to do the deployment alone, you could do it in SageMaker. You could have done the training elsewhere in your data center, take the model, give the model to us and say, hey, do the deployment for me, so that you could use the features like versioning and then A/B testing, auto scaling. If you want to just use only SageMaker deployment, you could still do it. That's why we call SageMaker as modular. You could define which one you wanted to use, right? So this is again getting into a little bit more details on each of this feature. As I said, we provide you a notebook service where you could author your notebook, and it has an Anaconda installed. So basically, it's a Jupyter notebook, and this has Anaconda libraries, installed on it. All your data is stored in EBS, so that you can switch on and switch off the instance. So you will be still able to retrieve the data and start working on it. Apart from that, we also provide some ready-made notebooks. For example, let's say in the retail world, one of the common use case people do is that they want to predict when the particular person will leave, right? Let's say if I'm running an telecom business, I wanted to see if the particular consumer of me, whether they will leave me or not, and that is called the churn prediction. That's one of the popular things which people do, right? So these notebooks are already created for you, right? All you have to do is that add your data, and then you could right away immediately start creating the models for you. So I'll show you some of the notebooks, that is ready-made notebooks that is available, that you could start using, that you could start using right away. Just bring in your data, execute the notebook, and your first model is created. You could start testing it right away, right? So that's on the exploratory data analysis. And then I spoke about the ML algorithm. As I said, Amazon provides 14 different algorithms as of now. When SageMaker was introduced, we are supporting about 10 different algorithms, and we are adding algorithms as we go ahead. Currently, we have about 14 algorithms like linear learner, factorization machine, XGBoost, image classification, object detection, k-means, if k nearest neighbor, LDA, NTM, blazing text. So, I mean, if you think about most of the problems, you could actually fit in one of these algorithms. So we, as I said, we support 14 different algorithms at this point of time. But then again, if you have developed your algorithm elsewhere, let's say in MXNet or TensorFlow, you could just import that code over here, right? Now we are also supported Chainer with it. So MXNet, TensorFlow, or Chainer. So if you already have that code developed elsewhere, or if you want to author something right from the scratch in a TensorFlow or MXNet, you could do it in the Jupyter notebook, which we provide, right? So we call that as a bring your own script. And then we also support something called bring your own algorithm. Let's say if you're not if you don't want to use the Amazon provided algorithms, or if you're not using the bring your own script model, let's say you have developed something already in PyTorch, right? That's one of the popular frameworks which people use. So if you've developed already one of the things in PyTorch, all you need to do, if you want to use the capability of the training and deployment that is there in SageMaker, all you need to do it is that create an Docker container. There are steps which we talk about how to create a Docker container, what's the folder structure it has to be. So create the Docker container, give us the Docker container, and from then you could start using the training and the deployment aspects of it. In fact, Puneeth from redBus would be talking about how they bring their own algorithm and they scale it on SageMaker, right? So purely from algorithm perspective, you could use this Amazon algorithm, or you can bring your own script, or you can bring your own algorithm, right? So these are the three options that is available. We also support Spark estimators. So basically, that is also supported in it, right? So I talked about so you have these algorithms, so you need to create a model, so you want to do a training basically, right? So the way it works is that once you select an algorithm, your training data needs to be in S3, which is our object storage. And so what SageMaker does is that it fetches the training data, runs your algorithm. Basically, you could say that, hey, I want to run this training in 10 different machines, 20 different machines distributed, run across 100 machines. It will take the algorithm, distribute it across this 100 different nodes which you have mentioned, get the training data, distribute the training data. So and it runs the training. Once the training job completes, it copies the artifacts, it copies the model and the image for that model into S3 and to a ECR repository. So again, we create it as a Docker container and save it. You don't need to get into the details, because internally that's how we store the data inside the Docker repository. So and we destroy all the training instances, right? So once we have the training data, run the algorithm, create a model, and then store the model securely, and then we will destroy all the training instances which you have brought up, and we will charge only for the amount of time the training done. If your whole training ran for about 1 hour, we will charge you only 1 hour for the training instances which were run. You could select while doing the training, you could select if you want to run it in a CPU machine or a GPU. That is an option that is available to you. And we also support something called hyperparameter optimization, which is a very key feature. I'll talk about it in the next slide, but I mean, I'll just park it for now. So HPO, hyperparameter optimization, is also supported, and this is all done in a fully managed, secure. You could do it inside your virtual private cloud, only where you have access to it at an extremely low cost, right? Because as I said, we charge you only for the amount of CPU time that is used, not even the startup time, the instant startup time, only the CPU time where your entire training was done. We charge you only for that, right? And the hyperparameter optimization is one of the features that was launched recently. It was in beta and it became live recently. So typically, hyperparameter optimization is nothing but, let's say if the algorithm author couldn't decide some value for you, they will ask you as a developer, they ask you as a developer to give the values to it, right? One of the common people who have been used to machine learning, learning rate is one of the popular parameter which you have to supply, right? But the problem with that is that let's say if you're new to machine learning and you don't understand a lot of this statistics and those kind of stuff, if the value, what value to give becomes a real it is not that easy actually. If you give a lower value, it might take, for example, if you take learning rate, if you give a lower value, it might take a lot of time for you to complete the training. But if you give a higher value, probably you might not get a proper output at all, right? So that is an issue which keeps happening. So what we have done is that for certain parameters, you could ask SageMaker to decide the value, right? Typically, hyperparameter is again a supervised machine learning regression problem. So where we would help you to decide that particular parameter. For somebody interested, we use Bayesian optimization, where we try to do an explore and exploit of this value and run multiple jobs to determine what would be the best value for this particular parameter, right? So that's the feature. So internally, to determine what is that feature, we use machine learning. So to give you that parameter, we internally run regression machine learning algorithms to find you and give you a better value. So for those values where you are not very sure, you could use this HPO technique to give you a better value for your specific problem statement. Thus, capability is now available in SageMaker, which you could start using. And the fourth aspect is deployment. As I said, once you have the model ready, you could say that, hey, I wanted to deploy. For example, on the right-hand side, you see that, right? We are saying that deploy that in auto scaling mode, have 5 instances and go up to 20 instances maximum, and the variant weight is 50. What that means is that 50, basically we are trying to do a A/B testing over here. We are saying that this particular model, send all the 50% of the traffic to this particular model. The green box gets in 30% of the traffic, and other gets in 10% of the traffic. So I can run 4 different models under one API, and then I can see how people are responding to it based on, let's say, if more the results is better than in the blue box, then I will make that as a primary model actually, right? So you could see that we support A/B testing, and also we support auto scaling here, because there where you see we have said that min instance count and max instance count, right? So the number of instances as and when the API requests, the number of people trying to inference increases, we can increase from 5 the instances to 20 and come back to 5 if the load is not there, right? So that's the deployment feature that is available with SageMaker, right? So again, this is modular. You could use only some of the features which you wanted, like the training or deployment. You could choose which one you want to use. I'll quickly show you in the next 5 minutes the SageMaker console. So this is the AWS console. So when you log in, giving your user ID, password, this is where you would get in, and then you could say SageMaker. So go to the SageMaker console. So this is how the SageMaker console kind of looks like, and you would want to go create a notebook instance. I have multiple notebook instances, but when you first go, this will be empty. You could say that create a notebook instance for me, give it a name, and you could select what type of in which type of instance this notebook has to be run. As you could see, we have different configuration, and these are all the P2 P3 systems, or the latest generation systems which we have. These are the GPU NVIDIA GPU based machines. So if you wanted, you could also do you could create your notebooks using this, but we generally don't recommend creating a notebook instance in a big higher class machine. The simple reason is that this well, our philosophy is that you run the Jupyter notebook as only the authoring environment. You want to offload your entire training job to other machines, basically, right? So you through an API, you want to offload the training jobs, which will run and destroy once the training is done. So you really don't want to use the notebook instance as a very high instance type. So probably you might want to start it as a smaller instance, like a M4 X large or something like that, and then you say go create a notebook instance for me. This will take about 2 to 3 minutes to create a notebook instance. So I'm going to use an existing notebook which I created. So once the notebook is successful, you will see that the notebook is created. So I just go to open, and this takes you to this particular page. I told you that there are already SageMakers gives you an example and other SageMaker algorithm that is available to you, right? So if you go to the SageMaker example tab, you could go see some of the already available examples that is over there. If you want to do a breast cancer prediction, that notebook is already there. You just need to give a data and start using it. I talked about churn prediction. If you want to do a churn prediction, we use the execute algorithm to do a churn prediction. So just click on it, pass in your data, you are all ready to go, basically, right? We will be able to create a model for you. And all the Amazon algorithms are present over here in this tab. So there are 14 different algorithms which I spoke about it. So those are present over here, which you say that a use, and then it will open up that Python notebook, basically in the Jupyter console. Then you could start using it. For example, I opened up this XGBoost a linear learner algorithm with MNIST. So this is how your algorithm looks like. The Python page looks like. So what you need to do is that this is the code where this place would be empty when you first open. You need to give a S3 bucket name where you have to put your training data. That's the only change I have made in this notebook. I took the existing notebook. I need to tell where I'm going to store my training data in a S3 bucket. I created a bucket called Praveen SageMaker 12. So that's where I put my data over there. And then if I want to if I want to make changes, all you can do is that you keep on executing it. So when you do execute like this, it will go run this particular command. Then you could go keep doing it. And finally, here in this notebook, what I'm trying to do is that I'm trying to find if the handwritten digit is 0 or not, basically, right? And finally, there is a prediction that comes out with it. So you could completely run. I mean, this whole algorithm, it took me basically about 20-25 minutes to run it. I'll quickly show you where this one-click training happens. Just give me 1 second. So all I am saying, this is where the training happens for this job, right? I told you, right? So you could just make a single API call to make the training. Here I'm saying that in the number of instances to the training I want is 1. If the data size is really huge, I can go ahead and make it as I want 100 instances. And I'm saying that I want to run these instances in a C4X large machine. That is a kind of a machine with certain CPU and certain memory. You could Google about what is this memory and memory and the CPU for C4X large. You'd be able to find it out, and then say that, hey, this is the output path where I want to store the model which is created. Then just start executing it. Then say linear.fit. Then the training starts happening over here. Here, if you see that we are not running the training in the Jupyter instances, we are offloading the training to a separate set of instances. This is why I said don't select IN machines when you're trying to do, when you're creating the notebook. You can start off with a small instance, offload the training and deployment to other instances. So this is where we do the training, just one-click training. And then this is how you do a deployment. Again, deployment, you say that linear.deploy, and then say the type of machine where you want to deploy. Here, I'm not doing auto scaling, or I'm not doing a A/B testing. There are other examples where you could see it. Here, I'm just deploying the model that is created, and I'm just deploying it for you, right? So just to go back, so as I said, these are all the 4 different features. I gave a quick overview on how the SageMaker console looks like, right? So now I'll bring in, at this time, I'll bring in Puneeth. Puneeth Kadamba is the engineering manager in redBus. So he will talk about how they are using SageMaker, in the sense that they are using bring your own algorithm, and he will walk us through on how they are using it, how they are scaling using SageMaker. Puneeth, over to you.
Hey, hi Brian. Thanks for the wonderful overview of the all the services and systems which are provided by AWS SageMaker. So I'm pretty sure that a lot of people who have gone through this training have been already thinking about applying their machine learning concepts into the problems which are they're facing day in and day out, right? But before we get into any machine learning problems, we'll have to keep certain things in mind, and probably we'll have to see how we can apply any machine learning problem into our existing set of items. So it is pretty sure that all the organizations are looking forward to be competitive in the market, and they're trying to do innovate something or the other. But at the same time, we have to give more importance to what the data looks like, and we'll have to do a lot of homework in terms of the data and how the machine learning problem would solve the particular problem at hand. So one couple of things which I would suggest is that machine learning, before getting into any machine learning problems, is we'll have to think in terms of what is the output of this machine learning solution. So we'll have to see how this impacts our business ROI, or how it helps our strategies in terms of campaign burning and all other stuff. And at the last, whatever we do is for mostly for customer experience, and we'll have to think how this machine learning problems helps us improve the customer experience. So talking about redBus and machine learning, we have a dedicated team of engineers working on data science and data platform teams who deal with a lot of complex projects like dynamic pricing, route planner, and let's say the ETA prediction. However, we are also trying to build a parallel team who are more enthusiastic in terms of machine learning apart from their daily activities. So, which is mostly driven by self-learning with the help of, let's say, SageMaker or any other forums. So, few of the problems which we solve with this secondary team are mostly like, say, if you start talking about some of the problems, one classic example is review classification, wherein we were able to classify the reviews which we get from users as a user generated content into more readable format, somewhat like this, where we were able to predict the type of category for the each review, and we were also able to put some sentiment analysis over there. And this is a classic multi-label classification problem which we are able to solve with a lot of help from SageMaker using the one of the algorithms which we were mentioning earlier, the blazing text algorithm, which deals more with text classification and handling the text problems. So moving on, some of the other examples are the support case categorizations, wherein the support tickets which comes in from the customers to our support agents, we are able to categorize them according to the relevance, and we were able to predict the priority of them and give a better user experience and solutions with a defined TAG program. So that has helped us in a very well structured way of solving the customer issues. So the customer ranking system is one of the models which are mostly adopted by a lot of organizations going forward. When I say customer ranking is, it means that we are able to rank a particular customer who's coming into the platform based on his actions throughout the funnel, right? So when a customer is entering your entering your platform and is moving across your home to payment page or order page, we start assigning some weights for it, and we rank the customer. So the usage of this ranks will be very much important in terms of recommendation and personalization and persuasion and whatnot. So when I say persuasion and personalization, with this particular ranking and what a lot of machine learning about a particular individual or a customer, we are able to suggest a lot of features to the user which are more relevant to him and which will definitely convert directly into better CRs and better adaptation rates. So personalization and persuasion are mostly the talking factors of a lot of organization, and as I said, your CRs and growth in the market is directly proportional to how well your personalization model is trained or how accurate they can be at a certain time. So lastly, chatbots, as you are talking about the services provided by Amazon, Amazon Lex is one such service which helps in automating the AI part of the chatbots, and a lot of organizations are looking forward to moving into the AI and conversational platforms where where we are able to connect to the users in a more conversational manner. And obviously, the reputation of the organization depends on how you are able to respond to the users on a conversational platform with a lot of machine learning involved, and how relevant that information is to the user. So these are some of the projects which redBus is working in terms of AI and ML. And talking about how SageMaker helps us is, as you mentioned and you showed as well. So there is a very well documented process and, let's say, the detailed uh, information about the algorithms which are available and support which are already available. Very useful for beginners, including me, as in we had a team of 3-4 members. We were able to do this on a self-paced learning using all this information and the GitHub links and the blocks on AWS. So that was a very good learning curve for us. And yeah, as you said, wide range of algorithms and the libraries. So as you said, the TensorFlow support helps in the deep network, deep neural networks and convolutional neural networks, which is a very wide used use case for most of the machine learning problems. And the most important part, which I like about AWS SageMaker support, is the automated scaling. To give an insight into it, when I was talking about the customer ranking system, so we would be expecting close to 10K requests per minute for this prediction system, where we are able to predict the customer rank. And let's say, suppose we recommend a particular offer to the user on the homepage itself. So as it is known that the traffic on the homepage is certainly huge, and if you are trying to predict something at that scale, then obviously the inbuilt support of SageMaker in terms of scaling and other infrastructure handling is a very much need of the hour, and obviously SageMaker supports to a greater extent. And as you were talking about monitoring as well, monitoring is one best thing which I personally liked about SageMaker, and few of the samples where we have the entire logs and the metrics. We get the invocation logs and metrics as well, and metrics, as it clearly shows, we can able to track CPU, memory, and disk utilization for each of the instances, and we can tune our scaling details, and we scaling the servers, and all those feedbacks goes into the model. And most importantly, for any developer as such, it will be I mean, they will be concentrating more on building the models and concentrating on tuning the accuracy of the models rather than worrying too much about the infrastructure, which is definitely taken care by SageMaker at this point of time. So the other use case where we're talking about bringing our own model into SageMaker, right? So that is I mean, that was one of our use cases where we were able to get in uh, the scikit-learn model, which we built on our own, into the SageMaker setup, where, as you said, we have to get the uh, image ready, and we'll have to configure all those things on the SageMaker, and we were able to host our own models onto SageMaker without much hassle. So, I mean, and I've been keeping track of all the things which are being added onto SageMaker. As you said, in a couple of months we have added few more algorithms, and definitely it helps going forward for any organization who has adapted to SageMaker. Praveen, do you want to add anything on that?
Sure, Puneeth. Yeah, thanks for it. So I've been answering a few of the questions in the question answer section. So one of the probably I'll take a few questions. So most of the people have asked, can you provide the recorded video? We will send the recorded video. So that we will do it. And one of the questions, let me take one question. So somebody asked, what are the typical charges that would be involved when you run SageMaker? So if you really see, the first charge would be you are running your notebook training instance. Correct. So that, for example, let's say if you're running in your notebook training instance in a T2 large machine, that's one charge you would incur. And then let's say you are doing the training. So while doing the training, you could say that, hey, I want to do the training in a two instances, and probably that training ran for about 30 minutes, right? So you will be charged for those two instances. Once you do the training, you get a model and you deploy the model. Generally, you deploy the model 24/7, right? You're not going to bring it unless, and I mean, if you're just using the testing, yeah, you might bring it down. But generally, if you're in a production environment, you deploy the model and it runs for it. So that is again another charge you will be charged, and you would be storing your data in S3. So that's again another charge, right? So these are typically the charges that would be involved when you're using SageMaker. Okay. So the next question is on, somebody asked about, what's the difference between, I mean, what's the relationship between Greengrass and SageMaker, right? So Greengrass is part of our IoT service, so which is deployed closer to the customer environment, basically. So the whole idea when we started Greengrass was that instead of, let's say, I'm in a factory environment where the factory has multiple sensors. Let's say there's hundreds of sensors over there. Instead of all the 100 sensors sending the data to the cloud, the idea is that can we have a local kind of a gateway inside the factory which will collect all the data from the sensor, and it can do some amount of pre-processing closer to in the factory premises itself, and send only some of the data to the cloud. That was the idea where the whole greengrass was born. So it's, as I said, it's part of our IoT service. Now what capability we have brought into greengrass is that, let's say you are doing you are trying to do a predictive maintenance, right? You want to predict if the particular machine would fail or not based on the sensor data that is coming in, right? So you could do all the training and everything in the SageMaker, create a model. So, and we provide the ability to take the model from the SageMaker and deploy it in the greengrass, right? So now the greengrass is residing closer in the same example of the factory. The greengrass is a software which is there in the factory premises. So I take the model from the SageMaker, which is in the cloud. I deploy the model in the greengrass, and now I can actually have the ability to do the inference. So whenever the data from the sensors is coming, greengrass, there's a lambda function which runs, Think of it as more like a compute function which it runs. It can get the data, do your predictive maintenance. I mean, see that if the particular machine is going to die or not, or is going to get into a repair, you could do it. So you could take the model out of SageMaker and kind of put it over there in the green grass, right? So that's one thing. Uh, okay, the next question, I'm just seeing if there is any question to Puneeth. So there is one question to Puneeth. So the question is, Puneeth, can you please show some sample workflow from training data stage till prediction model stage? This is one of the questions. So Puneeth, you want to answer this? I mean, the question is that how do you do from the training data? How do you take it to the prediction is one question. Probably you answered it, but probably you want to give some more context to it.
Yeah, so as I said, one of the examples which we did was we mostly use this scikit-learn model where we had trained the the model on our own, and we hosted it onto the SageMaker. So the training typically, as you explained in one a couple of slides, right? So how do you slice and dice the data, and how do you split it across training and testing phase? That is the whole key, as in I would say more than 50% of your machine learning problem is always on how you structure your data and how you clean the data. So that is, I mean, that is mostly what we did. Was it was done on our own, but with the help of notebooks, as well as we were, to be frank, we were hosting, I mean, we were setting up Anaconda on our machines, and we were working with that, where we were at some point of times, the machines which we use, laptops were not responding. So the example where you gave, where we can choose the type of the machine for the notebook instance itself, that is one more advantage where we had, where we could use a better computing machine, where we could use those to run our sample scripts and understand if it is working as expected. So I'm talking about deploying, and SageMaker already provides a framework on how to get your model onto SageMaker, where we have the defined, there is a build and push script for your image itself already. So on the ECR, so where you just have to give your, IMA details, and let's say which region you have to be pushing this repository into. So, and you just have to copy that repository information onto the SageMaker portal. Just let me just go through this. Yeah. So basically, the endpoints and endpoint configurations where you can, right. So this is one of the endpoints which we had created. So you can just
Sure.
go ahead and do a create endpoint, where you can give your endpoint configuration, and you have to create endpoint configuration and give the image path, the repository image path onto the endpoint, and that will load onto your model into the endpoint, and expose an endpoint over the basically endpoint onto your endpoint is created, and that endpoint is exposed as an API to be accessed or any HTTP network. So when you are when you are writing the models, right? So this is one of the, as I was talking, this is the build command, where you can build your image and push it over to the repository. And yeah, so the Docker build and Docker push commands are there. And this is where your main logic sits in. So this is the APIs are hosted on Flask and other built-in libraries. And so your basic logic of your predictions is in this predict API, which is the root is already defined over there by SageMaker, where you'll have to give the roots, and whatever you have to loading, you have to load the model into it. And let's say the prediction logic sits over here, and you'll have to return the prediction in a required format. So, and all those other things are taken care by SageMaker itself.
Yeah. Thanks, Puneeth. I mean,
Yeah.
completed, or you have something, Puneeth, or
Yeah.
can I
So
go
that's
into the?
pretty much
Yeah.
it. So it's very, very straightforward. Yeah.
Yeah. Okay, so I'll go ahead with the other questions. So one of the questions was whatever data I'll put in S3 for model training, are those data private to me only, or Amazon also use internally for analytics? So the question, so basically any data you put in S3, you own it. Amazon doesn't even have access to the data. So all the data you put it over there, it's completely owned by you. We don't have any access, so there is no question of us using for any analytics or not. So we also provide you multiple ways to encrypt your data as well. So Amazon SageMaker can understand, let's say you could, while putting the data in S3, we provide you multiple different ways of encrypting the data. There is something called KMS, Key Management Service, where you could bring your own key and encrypt the data. And SageMaker, you could also import that key into SageMaker, and then SageMaker can understand when it is reading the data from S3, it will decrypt it and run it for you, right? So there are multiple ways. If you want protect your data, there's multiple ways you could do it actually, right? Um, we spoke about green grass. So there was a question on can I use any of the existing EC2 instance for this purpose? The answer is no. So when you see when we created the SageMaker notebook, we selected something called ml.t2 x large or ml.m4 x large, m4 large, something like that. So these are the machines specifically done for the machine learning problem. So you cannot use an existing EC2 instance for SageMaker. I mean, to run it in SageMaker. If you want to run your own algorithms, then you could use the regular EC2 instance. But with SageMaker, for both the training, deployment, and running the notebook services, you would be needing to use the ML kind of machine. In fact, those machines, if you go to your list of EC2 instances, you wouldn't even see it over there. It runs in a separate environment. So the answer to the question is that yeah, you cannot use your existing EC2 instance to run it actually. Okay. So another question was, does SageMaker provide any algorithm for multiple object detection? Yes, we recently launched an algorithm through which you can do object detection, multi-object detection. That is currently available. So I think it is available for the last 2 months or so, right? Um, and how can we access the deployed model in SageMaker? Okay, so a couple of things which I want to explain here. Basically, the SageMaker we saw is in from the Jupyter environment. We have been calling the SageMaker training service and deploy service as well, right? I said SageMaker is a modular environment where you could use only the training or deployment alone. Let's say you have your Jupyter environment running in your laptop, right? Very well, a lot of people do it, right? So you have your Jupyter environment running your laptop. SageMaker also provides you APIs to call the training and deployment as well. So from your notebook, from your laptop Jupyter notebook environment, you could make a call, API call, to start off a training job, and also to start off a deployment also you could do it actually, right? So that is possible to do it via APIs. That is available for you. And to the specific question on how do I take the model and use it, so based on the type of the model, based on the type of algorithm, it generates different types of model. So based on the model, we have articles and links which talks about how can you take the model out, what are the dependencies. For example, let's say if you have created the model using MXNet or a TensorFlow, there are certain dependencies that you need to carry. If you're taking out the deploy, if you're taking out the model from SageMaker and want to deploy it in your environment, you have to carry those dependencies as well, which is documented. But if you are going to deploy it within SageMaker, then SageMaker takes care of putting the dependencies in the deployment environment. So that is the difference. So do you also provide some sample training data for some of the algorithms supported by SageMaker? Yes, I mean, so one of the common things for classification and you see over there, and also for credit card fraud, if you want to run, there are some sample trainings. Basically, for handwriting recognition, we use this MNIST training data set, which is very popular, right? So that is available. That training data set is available. All you need to do is that give us your bucket name and then execute it. We will download that particular MNIST data set for you, right? So like the same way for credit card fraud, we have from Kaggle, we have downloaded some data set which you could copy, right? So for some of the algorithms, we have data set, but the whole idea here is that you are doing it for your own use case, basically, right? You want to predict, or you want to do a churn prediction of your customer. You want to do some fraud analysis on your use cases. All the training data and other things we provide would be generic, and it could be used for your understanding and learning purpose. Yeah, there are certain things like handwriting recognition. You could use the MNIST data set, which is very common. A lot of people use it. But based on the use case, you might want to select the data that is specific to your environment, and you might want to start using it actually, right? So that is the idea over here. uh, I'm just seeing. So can you explain the algorithms used in SageMaker? Okay, so the good page here would be to go to SageMaker. If you type in Google for SageMaker algorithms, it takes you to a page within the SageMaker where it talks about each of the 14 algorithms that we have in a very detailed format. It talks about what are the different use cases you could solve using that particular algorithm. For example, if you take linear learner as the first algorithm that will show up, you can say that, hey, whether how do you use it for a regression, how do you use it for classification. It can be used for both the purpose. Then it talks about for what kind of use case it can be used. Then it also has a detailed explanation about what are the parameters that needs to be passed, right? Because I said that there is a concept called hyperparameter. When the algorithm author not able to decide a value, they will set it as a parameter, like what we do it in a normal programming. So the algorithm author will also give you a parameters. It lists down each of the parameters and explains you what that parameters means, what is that, and what is the for some cases they might have set the default value. It also talks about what is the default value that has been set over there, right? So that's the information it would have. uh, So can we have another session on detailed analysis and sum of all learning algorithms? So this is a 1 hour session. So we were like theoretically covering what is the capability of AWS, but we will be doing a lot more hands-on session in future where it will be like a half a day, 1 day session where we will be doing a lot of labs and those kind of stuff. So I mean, keep looking at your mails. There'll be one that would happen near your definitely near your city actually. And then, so we have 2 minutes probably. I can take one more question. So, session. I wanted to understand the connectivity with SageMaker. So I didn't fully understand the question, but at a very high level, SageMaker basically can be run within your VPC. So if you have been used to AWS, VPC is a concept where you create your own network environment, and so Amazon SageMaker can be run within your VPC in that sense, so that it could access your resources and all those stuff. If you have your database running, you want to connect to it, you could still do it from the Jupyter environment. You can still do it from the Jupyter environment. And let's say if you want to VPN into it, if you want to create a virtual private network, that is also possible because it's inside your VPC. So from your local office, if you connect it via VPN, you could access it, right? So it is, think of it more like a typical EC2 instance that you get access to. It's the same concept that is applied for this as well, right? So at this point of time, we are at 3:29, so I'm sensitive of the time, so we have to close this. So what we will do is that we will, by end of this session, we will send you the feedback form, please fill up the feedback form. And I know there are some questions which we were not able to answer, so you could put in your questions in that as well, and then we will try to answer those questions offline. Probably we'll send you a mail on that, right? Yeah. So thanks everyone for joining. Thanks Puneeth for taking time out and explaining the redBus, how it has been implemented in redBus.
Thanks, Brian.
And thanks for all the participants. And thanks for all the participants for your time. Thank you.